It looks like a couple more people still need to check in. That's okay. For now, I want to review just a little bit about what we did last week and also go over questions that you had on your homework. So I'm going to give a couple, about a minute or so. If you had questions over the homework, please just put them in the chat or email them to me. You can also screenshot it and email to me, and I'll help you out. Um, I think it should be pretty straightforward because we've been doing this for about a week and a half now, and it's pretty much the same thing. But if you do have questions, ask them now, and then we'll get going on newer stuff. All right then. Since there are no questions over this, or at least no one's asked, a couple things I want to do. I want to review just a little bit, and then I want to go over inverse trig and then solving entire right triangles, which is where we're going to be headed. So first, let's recall what we did last week. Okay, so last week and even a little bit the week before, um, we have defined what sides we have given an angle in a right triangle. So we should be able to find hypotenuse, we should be able to find the opposite, and we should be able to find the adjacent sides. Okay, and from those, there are certain relationships of the angle theta with different ratios of different sides. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Then we went over reciprocal functions, which are cosecant, secant, and cotangent. Right, so cosecant is just hypotenuse over opposite, secant is hypotenuse over adjacent, cotangent is adjacent over opposite. All right, and then with all of that, if we are given two sides of a right triangle, we can find the third by plugging that into the Pythagorean theorem, which is opposite squared plus adjacent squared is equal to hypotenuse squared. Right. When you are doing the formula opposite squared plus adjacent squared equals hypotenuse, do you keep those simplified when you find the missing piece you were looking for? It's kind of up to you. Usually, if you simplify it up front, it makes some calculations a little bit later a little bit easier. So, for instance, if you get like, well, it, usually if you simplify it right off the bat in the Pythagorean theorem, it makes rationalizing those trig functions later easier. Okay, so you don't have to, but it's usually easier to rationalize smaller fractions than it is a lot bigger fractions. So I would say just rationalize it every step of the way. That way you're not dealing with huge numbers under radicals where you aren't really sure what perfect squares go into what. Is there an easier way to remember cosecant, secant, and cotangent, like an acronym for them? Not really. That's just something you got to memorize. Yeah, cotangent should be the easiest. Tangent and cotangent, those should be very very simple. Cosine to secant and sine to cosecant. I always think the regular switches letters, so yeah, there's not really an easy acronym. It's just something you kind of got to memorize. Luckily for right now, you should be seeing this a whole lot. Uh, because it's right in front of you pretty much the entire time. Um, but yeah, there's no acronym, at least that I know. If someone finds one, I'll put it up. But as of right now, no. Okay. And within all of that, we've dealt a lot with rationals or radicals, and we've rationalized a lot of fractions. And I get that that's usually probably the hard part in all of this. But again, as you get better, as you practice this, it gets a little bit easier every time you do it. Okay. And with more experience, it becomes just kind of second nature. Right. So again, I'm going to pause for a second. If you have any questions over any of that, now would be a great time to ask. And if I didn't necessarily answer your question, um, that it again, ask it again or in a different way, and I'll try and help you out. All right. So now we're going to start to do is use inverse trig. And I'm going to break it down in a couple of different ways, one of which is on screen, and then I'll kind of talk through it as I go. So regular trig is what we've been doing. So that's SOHCAHTOA and the reciprocal functions. Okay. So SOHCAHTOA, keep in mind that sine is just a ratio of sides. So sine of some angle is the ratio of opposite and hypotenuse. It gives a relationship of an angle and sides. And the same thing is true for cosine and tangent. Okay, so our regular trig, just to repeat, gives ratios of different sides given a certain angle. Okay, so all we've dealt with so far is just sine of an angle is a ratio of two sides. Or cosine of an angle is the ratio of two sides, or tangent, and so on. Okay, inverse trig undoes that trig function. Okay, so it will undo the sine, cosine, or tangent in order to solve for the actual angle theta. Okay, so what I like to think about are the inverse functions that you kind of already know. All right, so the reciprocal or the inverse function of addition is subtraction. Okay, because subtraction and addition undo one another. The inverse function of multiplication is division, right? So a really quick example of that is 2 over 1 times 1/2. That is multiplying by the reciprocal and therefore undoing one another. Right, so you know inverse functions: addition and subtraction, multiplication, division, squaring and square rooting. Okay, it's the same thing for inverse trig functions. Right, and what those look like is what I have down at the bottom of the screen. All right, so you will normally see an inverse function look like sine to the power of -1. What that means is just sine inverse or inverse sine. And when you take the inverse sine of a sine function, so the inverse sine of theta, that just leaves theta. And then the same thing is true for cosine and tangent. Okay, so I'm going to pause and let people kind of catch up. And if you have any questions, let me know. Okay. So again, that sine -1, cosine -1, tangent -1, that undoes sine, cosine, and tangent. All right. And here in a second, so if you have a calculator, now would be a great time to get it out. In order to get these things on a calculator, you hit the second button, and then you hit the sine, cosine, or tangent. And if you do not have a calculator, there is still a way. You can go to Google, and if you can't see that, make it a little bit bigger. Not that big. You would type in sine caret -1, open parentheses, whatever you're taking the sine of, close parentheses, and then in degrees, and that'll give you theta. Okay, that doesn't make a whole lot of sense right now, so let's get to an example. All right, so something that you'll see in your homework is find the value of x in degrees. So what we're trying to do is we're trying to solve for the angle now. All right, so in the past, we've gotten the ratio of sides. Now we're actually trying to find the angle. All right, so in order to solve, say, this number 1, we want to get x by itself. In order to do that, we have to take the inverse sine of both sides, because that will isolate our x. And because we do it on the left-hand side, we also have to do it on the right-hand side. And when we do that, this sine inverse and this sine, they cancel each other out. They undo one another. And we're left with just x. On the left-hand side, at least. And then on the right-hand side, we still have this sine inverse of √3/2. Okay, so that's kind of why this is working. We have two functions that undo one another. We're left with what's inside parentheses. And then on the right-hand side, we have something that we can evaluate. Okay, so again, I'm going to pause. And if you have questions, now would be a great time. And then after that, we'll actually get a number. All right. So in order to get a number, we would just type in what I have in the green box into a calculator, and you'll get a number. Now it's important, and I'll write this out, that you write it very carefully. So the first thing that we need is the sine inverse, and in order to do that, we hit the second button, and then the sine button, and then we would do square root of 3 divided by 2. And again, you can type this into Google, you can type this into Desmos. Most calculators will have this. And then once you have that typed out, you hit enter, and then you should get 60. And if you don't, if you get some decimal, we need to change the mode. So you'd hit second, and then, oh wait, not second. You just hit mode, scroll down to radians and degrees, and we want degrees. So if you get something that looks like 1.0472, that is in radians, which we're not going to worry about for right now. And they're just two different units of measurement. They mean kind of the same thing, but we want the degrees unit. Okay. So again, I'm gonna pause because this is a little bit different because people are trying to follow along on the calculator. I'm not sure what calculators you have. So I'm gonna pause. If there are any questions, please let me know. How did I get the exact degrees? So when you take the inverse sine of root 3 divided by 2, that will give you the degrees. Okay, so there are two different calculator modes, okay? One is in degrees and one is in radians. Some calculators in default are degrees, some are in default radians. All right, and if you have a TI-84, so like one of the big ones, or a TI-83, in order to change that mode, on the second row, right by the second button, there's a mode button. You would hit that, go down to where you see radians and degrees, highlight degrees and hit enter. And then that'll change the unit of measurement. There is no exponent function on Google. So in order to type that out, it would look like this that I have on screen. So sine caret -1, and then in parentheses, we would type so that's sine inverse of square root of 3 divided by 2. And I'm just going to make a quick ask, I guess. If you do not have a TI-84 or a TI-83, now is a fantastic time to get one. Because as we do this stuff, the more that I can help you out on this calculator, the better. You're allowed to have it on the ACT. You're allowed to have it on any standardized test. And it can save you a whole lot of time and work on very important tests. The key doesn't work next to the sine symbol. I would just type this out. So you're not necessarily using Google's keys, you're using your own keyboard. Okay, so again, if you're able to get a TI-84 or a TI-83, now is a great time to do it because it can save us a whole lot of time and make us a whole lot more efficient on very important tests. Okay, so I'm going to move on to the next one, and we can kind of go through more examples, all right? So this second one, cosine of x is equal to the square root of 2 divided by 2. And we want to find the value of x in degrees, right? So if we're going to show our work, in order to undo that cosine, we have to take the cosine inverse of both sides. And when we do that, this cosine inverse and this cosine undo one another, and we're just left with x. And then the right-hand side is cosine inverse of root 2 divided by 2. And when you plug that into a calculator or type it out, you should get that this is equal to 45 degrees. And then on the third one, it's basically the same thing. When I try to do it on my calculator, it just says either domain error or syntax error. You need to make sure you type it in very, very carefully. All right, so I usually overdo parentheses. So again, on this sine example, I would type it in exactly like that. How did you get 45 degrees? You won't get 45 degrees, you'll just get the number 45. So all we're doing right now is entering the value of sine, cosine, tangent, but with the second function in front of it, right? Pretty much. This is all calculator work. That's what I did, but it just said domain error. I would check your mode maybe, or make sure you're actually doing sine inverse as opposed to sine. If you're getting a domain error, you're typing in something wrong. Okay, so you have to have sine inverse or cosine inverse, and then you have to very, very carefully type in square root of 2 divided by 2 or square root of 3 divided by 2. Okay, and what you can do is you can do, so let's take this top green example. Well, I wouldn't do that. So when I'm typing this in, we hit second sine. Where do I go to mode? There's a bunch of letters, but none of them say mode. Some calculators won't have mode. I understand everything about this, but how do you get 45? How did you go from radical 2 over 2 and get 45? We didn't go from radical 2 over 2. We went from cosine inverse of radical 2 over 2. All right, so I need to pull up a calculator here and actually show you. Okay, so this is Desmos. If you need it, just Google Desmos. It's like the first option. All right, we want to get. Actually, I'm just going to use Google. This is more graphing. Well, we can try it. All right. So when we type this in, and I typed in it exactly as I showed you on screen, um, we get this 1.0472. And I think there's a way to get this in. Degrees. All right, so in Desmos, You type it in exactly as I had it on screen. When you first type it in, you'll get 1.04 something right here. In order to change that, you go to this wrench icon, graph settings, hit that, and at the bottom, you have options for radians and degrees. You hit degrees, and then it'll change that radian into a degree. Okay, if I do the second one, cosine, that up caret, -1, arrow button to the right, open parentheses, and we want square root 2. Scroll to the right, divided by 2, scroll to the right again, close the parentheses, enter, and you'll get 45. Yeah, so you cannot do this in your head, at least not yet. This is something that you'll go over more next year with circles that'll make a little bit more sense, at least graphically. But right now we're just working with right triangles. Yeah, so you can click the keyboard at the bottom as well. All right, so again, if we wanted cosine, we can go to functions. It's there. And we want square root of 2. We'd have to scroll over 1 and then divide it by 2. Hit enter, get the same thing. This is part of the reason that it's very important to have a graphing calculator. Okay, because all of this stuff is streamlined and it's a lot easier. And then when you get to the ACT or the SAT, when a question like this pops up, it's very easy to do. Okay, so I'm going to close that for a second, and I want to do another couple of examples. All right, so on this third one, again, we want to undo tangent. So we have to take the inverse tangent of both sides. So you would recommend Desmos for this. If you don't have a graphing calculator, then yeah, use Desmos. Again, though, it's a lot easier if you have a graphing calculator. All right, and then when we take the inverse tangent of both sides, we're just left with x. Inverse tan of root 3 divided by 2. And then we would plug that into a calculator or Desmos and get an answer. Okay, so when we do that, we will get so I got 40 on my calculator, 40.89. So I'll go over and show you how to do it on Desmos. So we'd get inverse tangent. Oh, that's root 3 over 3. Sorry, I typed that in wrong. Should get 30. So if we do that on Desmos, yeah, it should be 30. Functions, inverse tan, and then we want root 3, scroll 1 to the right, divided by 3, and then hit enter, and we get 30 degrees. Okay, so again, this kind of takes practice. Doing this for the first couple of times, you might not be sure exactly what to type. Um, the more examples you do of this, the better you'll get and the quicker it'll be. Okay, for now though, I want to go over two different types of examples. So the first are the reciprocal functions. So say we have the cotangent of x is equal to 3. And again, we want to solve for x. All right, in order to do that, when we have a reciprocal function, the first thing we need to do is to change it to our regular function. All right, so keep in mind, cotangent is adjacent over hypotenuse, over opposite. All right, so this root 3 is really root 3 divided by 1, which means this numerator is our adjacent and this denominator is our opposite. Okay, so if we rewrite that in terms of tangent, we would get tangent of x is equal to 1 divided by root 3. Right, because tangent is opposite over adjacent. Okay, then we would just do what we did up top. Okay, so we would take the inverse tangent of both sides. When we do that, we would be left with x on the left hand, and then inverse tangent of 1 divided by root 3 on the right hand side. And because we're just typing this into a calculator, we don't necessarily have to rationalize this. All right, so we would just type in tangent inverse of 1 divided by root 3 and get an answer. And when we do that, we get 30 degrees. How are you getting tangent from this? Cotangent is the reciprocal function of tangent. All right, and we only have sine inverse, cosine inverse, and tangent inverse to work with. Okay, so we need to change cotangent into tangent. And we know that cotangent is adjacent over opposite. So if we just flip that fraction upside down, we get the tangent. So if we go back up top, right, cotangent is adjacent over opposite, tangent is opposite over adjacent. So we have the two numbers that we need. We just need to flip that fraction. All right, and cosecant of x is equal to 2. Again, cosecant, that is hypotenuse over opposite, which means that this 2 is the hypotenuse, this 1 is the opposite side. So we can rewrite this in terms of just sine. And then we solve using inverse trig, right? So we take the inverse sine of both sides. We're left with x on the left. And we want the inverse sine of 1/2. Which is just equal to 30. And on this third example, secant, that's hypotenuse over adjacent. Which means this numerator is the hypotenuse. This denominator is the adjacent side. So we can rewrite this in terms of cosine. Where cosine of x is equal to 1/3. And then again, we solve using inverse trig. So we take the inverse cosine of both sides. And we get cosine inverse of 1/3. And when we type that into a calculator or Desmos, we get 70.53 degrees. Okay, so I want to pause here because this is just a little bit different. Are there any questions over any of these examples or any of these concepts so far? Yes, you can get decimals from this. Just make sure that you're in degrees and not radians. Why in the first problem did you flip the 3/1 to 1/3? Well, in the first problem, it's square root of 3 divided by 1, right? But that's cotangent of x. And I did flip them for all the problems. Okay, so we need to rewrite cotangent in terms of tangent, cosecant in terms of sine, and secant in terms of cosine. So on this first problem, cotangent tells us that we have the adjacent over the hypotenuse. Or the opposite, sorry. Which means that we can rewrite this in terms of tangent, which is opposite over adjacent. So when we flip this fraction, we get this fraction. Okay, there's one more problem I want to go over. And that's kind of putting all this together. And we can call it here, all right? So this is kind of the second part of your homework, pulling trig and inverse trig together. All right, so given this right triangle, where we have one angle is equal to 60 degrees and one side is equal to 18. Okay, we want to find this side right here. So in order to do this, we have to pull together our trig ratios and use inverse trig. All right, so the first thing that we would do here is to just see what side we actually have. All right, so we have this side 18, which is opposite our right angle, which means that we have the hypotenuse. And we're trying to find the side opposite our angle. So in order to solve for this, first we have to set up an equation. Okay, so because we have, we're going to need to find the opposite side and we have the hypotenuse, we can write a function in terms of opposite and hypotenuse. So the sine of our angle will equal the opposite over the hypotenuse which is just equal to some unknown over 18. Okay, now we're trying to find for the opposite side. So what we would do is we would just evaluate sine of 60. All right, so if we plug sine 60 into a calculator or into Desmos, just regular sine, not inverse sine. We would get some decimal is equal to opposite over 18. And we would need to solve for that opposite side. So in order to do that, we have to multiply both sides by 18. And when we do that, we get 15.588 as our opposite side. And then that's our answer. Okay, so the first thing we have to do is we have to determine what sides we actually have and what side we actually need. All right, so again, the first step is to just define your sides. Then with those sides and the angle you're given, you need to set up an equation. And then everything else is just solving that equation. Again, so I'm going to pause for a second. Are there any questions over this example? Okay. How did you determine to use sine? All right. We are trying to find, so the question says, given this diagram, to find BC. All right. So this side is BC. All right. So again, the first thing, we just need to define our side. So given the angle, you should find the opposite side, the hypotenuse, and the adjacent, and just see what side you have and what side you need. So in this case, we're trying to find this opposite side. And we have the hypotenuse, so we can write a function in terms of sine. So define what side you have, define what side you need, and then write an equation with both of those things. When there's a problem with a root as a denominator, do you have to simplify before plugging into the calculator? No, that's the great thing about using a calculator. You don't have to rationalize or simplify it. Okay, I do have one more example. I'm going to let this go. Like I will do the example, but if you want to get started on your homework, you may do that. So your homework is R7 and R8, which are exactly like the examples that we just did. Okay, so everything that you will see on those IXLs we've already done. So if you need to go back and rewatch this or rewatch an example, you may do that, but it is the same concept. Okay, you use an inverse trig for the first one. Okay, so R7 is inverse trig. and R8 is just like the example that you see on your screen. Okay, so if you would like to get started on that, you may. I will start a Teams meeting here in the next like 5 or 6 minutes, depending on how long this next example takes. So if you want to get started, go for it. If you want to watch me do another example of this, you can stay as well. All right. Okay, so another example that comes from this IXL is the one that you see on your screen. And again, I took this directly from it. I think this is in like the mid 70s or mid 80s. Okay, so a pretty good example of what you'll have to do. All right, so given this diagram, we want to find Wx. All right, so again, the first thing we need to do is to define what sides we have and need. All right, so if we draw a line from our right angle to the other side of the triangle, that's our hypotenuse. If we draw a line from our angle to the other side of the triangle, that's our opposite. And the other side left, that's our adjacent side. All right, and we want to find Wx, which is the opposite side. So we need to find the opposite side, given the hypotenuse. So then we can set up an equation with opposite and a hypotenuse in it, which would be sine. So when we set up our equation, we do sine of our angle, in this case 44, is equal to the opposite over the hypotenuse. And the hypotenuse in this case is just 10. Okay, so I'm going to do this slightly different, and this is just the way that I like to do it. You can do it either way you want. I'm going to multiply by 10 on both sides first to get the opposite by itself. So then we have 10 times the sine of 44 is equal to the opposite side. And when you plug that into a calculator or Desmos, we get 6.95. And IXL will tell you where to round to. All right, so in this case, it tells you to round to the 100th. So our original answer is actually like 6.946. And we went to the round to the 100th, so this one goes up. So it's 6.95. Okay, questions on this example? All right, since there are no questions, I'm going to end this in the next like 10 or 15 seconds. And then I will start a meeting in Teams. And as you have more specific problems or questions, I will help you there. All right. So kind of last chance right now. And if there are none, I will close it. So I will close this. I'll be on Teams and I will start a meeting. So see you there.